Okay, so Peter's going to talk to us about opportunities in ground engineering and possibly taking some of these projects which we had last year forward.
Which one is it? Is that it? Just enter forward and stick if you.
I hope we won't need the stick. Well, good afternoon, everybody. As I said, my name is Peter Watson, Managing Director of Forgers Limited. We're a civil and ground engineering contractor. For those that you don't know us, I'll go through just a little bit of what we do. 25 to 30 million pound turnover. I suppose we're in the SME category again. We have about 230 staff, of which about 25 are technical staff, including chartered engineers and chartered geologists. We're based in West Bromwich, and we also have a base in Scotland at Grangemouth. We do a wide range of activities. First few are ground engineering activities, and that's what we're going to focus on a bit this afternoon. In particular, mine workings and mine shaft stabilisation, various specialist drilling and grouting functions, site investigation, soil nailing, ground anchoring, slope stabilisation, mini piling, deep wells, anything you can use a drilling rig for, basically. And a range of civils activities as well. I won't go into those in any particular detail. From the ground engineering perspective, and the reason we got associated with the university, we do a lot of mine workings treatment, primarily shallow mine workings consolidation, treatment of mine shafts, mine shaft capping, infilling of dangerous mineral mines, underground stabilisation works, and we're probably the largest UK mine workings treatment contractor. That might not mean anything to you, but it is actually quite a big field. And we treat coal, fire clay, ironstone, chalk sandstone, and many other minerals. Do a range of other specialist geotechnical activities as well, which include site investigation, standard rotary coring, probing, testing, instrumentation, geophysics and surveys, mention slope stabilisation, etc. We run a range of specialist drilling rigs, dual head rigs, which allow simultaneous casing of boreholes to significant depths, say 150 metres. They're ideal for drilling deep holes through unstable strata or through broken ground. One pass system, so as soon as you've drilled a hole, you can then install whatever you want to install, which could be piles, it could be monitoring. You can use those boreholes for installation of groundwater abstraction, for instance. You can use them for monitoring, for mine infilling. You can actually then use the casing as a direct infilling tube, shall we say. So you're injecting materials directly via the primary casing. So a wide range of opportunities from that type of drilling equipment. And we do a range of mini piling as well. But I suppose concentrating on mine workings treatment, which was where the association with the university developed, we carry out investigation, design and treatment of mine workings. It is perhaps a small but specialist and quite interesting area of ground engineering, and some of you may be aware of it, some of you may not be, but you'd be surprised at how much of the UK has been mined in the past. For coal, oil shale, fire clay, ironstone, lead, tin, chalk, limestone, gypsum, sandstone, salt, potash and other minerals. That little map there is the central belt of Scotland, from the Firth of Clyde to the Firth of Forth, and you can see how much of it has been mined. So mining itself, historical mining, can present a significant problem for development in any area that has been mined, and any development that is proposed in a mine working area will require a mining risk assessment to start with, and that will probably lead to investigation, drilling and design of treatment schemes prior to a development taking place. Now, much of the mining has obviously long since ceased. Mining started in Roman times and went on, particularly coal mining, went on until probably the 80s. Although the majority of the shallow mining, which is what we tend to get involved in treating, was early mining, and that's sort of 17th, 18th, 19th century mining, where obviously miners didn't have the technology at the time to go deeper, so they mined whatever they could as close to the surface as possible. And those are the mining legacies that tend to affect developments. Now, obviously, in terms of career opportunities, developers and clients, anyone wanting to develop a site which has a mine working legacy will require to appoint an expert geotechnical engineer as a business, and obviously those businesses will employ geotechnical engineers, geologists, who will undertake that investigation, that design. It obviously requires a wide range of engineering geology knowledge, including understanding of mining methods and collapse migration mechanisms, interpretation of rock strengths and the effects of overburden on mine systems, understanding of foundation designs and how they interact with mine workings, the presence of mine shafts and how, again, mine shafts interact and affect developments, where you can get sources of information, for instance, the Coal Authority or local archives, and the understanding of treatment techniques, designs and materials that are used in treatment works. While most mining in this country has ceased, this legacy will last for years and years and years, and so there is a long-term ground engineering and geotechnical opportunity for engineers for the foreseeable future. Just to give you a couple of examples, these on the left are diagrams of the different sorts of coal mining layouts that were carried out in different parts of this country. So even across the UK, miners in say different areas mined workings in a different way. So each of those will have produced a different collapse mechanism. And it's, I say, useful if you, if you're interested in this sort of career, to get a basic understanding of the types of mining, how mines were, accessed, carried out. Mines were accessed through adits, through shafts, even through seams cropping at surface. An understanding of how mining systems were supported, mine workings and mine shafts. You find that information is often sparse. Mine plans were not compulsory until after the 1870s, and of course a lot of mining was carried out before that. So a lot of mining information is actually unknown until you start to investigate it. Even then, the mine plans are often not accurate, because once the miners or once the mine owners had submitted their plans, they often used to rob the pillars and extract more coal or minerals than they were prepared to pay tax on, or they were prepared to declare tax on. So often mine plans have to be taken with a pinch of salt. But they are useful if you can align a mine plan with an existing surface feature, perhaps an old road or canal, etc., to to add that piece of information to a desk study or to an investigation. If you're not particularly aware of mine workings treatment schemes, they don't tend to get particularly publicised, but it is useful to note in terms of the scale of work, people who like to think they want to be involved with bigger schemes. I mean, my workings treatment contract values are regularly to over 6 million. And the largest contract undertaken in the UK was probably about 100 million, which was a limestone mine infilling scheme in Bath, which was undertaken from underground. So schemes are regularly quite large. An example is a scheme we completed last year and the year before, which was for the M8 motorway improvements in Scotland. Contract value of 6.5 million, and it involved over 10,000 drill holes, injecting over 80,000 tonnes of PFA cement grout, treating over 30 mine shafts along a 25 kilometre section of upgraded motorway. Obviously the original motorway hadn't been treated when it was first built, so the new motorway had to be fully treated. And we had 6 geotechnical staff on that contract for about 12 months. Picture below is just an example of a site with multiple outcropping coal seams. So on that site, the majority of that site will have to be drilled and grouted before any development can take place, because all those seams, or all the thicker seams, will have been worked in the past. Just examples, if you don't treat workings, these are 2 mine shafts that we were involved with. They both collapsed while we were treating them. So a lot of mine shafts in the past, when they were abandoned, they were just randomly filled. They were quite often worked at different levels, so you would have a staging perhaps at a level that might have been halfway up the shaft. And when the miners abandoned the shaft, they would just chuck everything down the shaft, and the staging would remain in place. And it remains at a sort of equilibrium until today. Now, when you drill it to treat it, if you drill through the staging, you'll cause the staging to collapse because it's probably pretty rotten, and the whole shaft collapses. So, 2 instances there. We're drilling off a platform, big platform on the left. That shaft's collapsed beneath the platform. On the right, we were drilling off a platform, and the collapse was bigger than the platform, so that the drilling rig has ended up down the hole, down the collapse crater. So, anecdotally, in the West Midlands, there are 10,000 recorded mine shafts. If you get a coal authority plot, it is just a mass of mine shafts. There are also anecdotally about 10,000 unrecorded mine shafts. And we recently treated a site in Bilston where I think there were 4 recorded mine shafts on the site, and we found another 25 shafts. All significant size shafts, all down to sort of 80 metres. So the sort of understanding of how mining was carried out, accessing all the old archive information, getting expert input is really, really important, because if you start building, this particular site was for a new academy, if you start building a lot of new buildings on top of a site that's riddled with mine shafts, then you're in for a surprise. So couple of typical slides for treatment works. Picture on the left, that's one of the sites on the M8 where we're drilling a lot of these holes are all, you end up treating mine workings in a grid of boreholes, which can vary anywhere between a 3 metre square grid to up to a 6 metre grid. And where you've got obstructions or you're drilling under embankments, and you'll drill angled holes at various angles to make sure you intercept the workings at the defined grid position, so you can ensure that the workings are fully treated. And drilling equipment these days is pretty versatile. The kinematics of modern drilling rigs are such that you can drill any angle, either in front of you or at the side of you, to make sure you get those arrays of drill holes to intersect and make sure everything's fully treated. But mine workings can vary in size. This photograph top left is a limestone mine in Dudley, and that is where the seam has been faulted. So that's an actual vertical seam of limestone, so it's one side of an anticline. So that the limestone has been worked in that gallery, but the material to the left, which is nodular beds, has actually started to collapse. So while you could access the mine at that time, that mine's now been filled. It was filled with sand, actually, that mine. Bottom left is an ironstone mine where we could access the mine from underground, and the funder, who happened to be as a government-funded project through the Land Stabilisation Programme, would only fund the treatment of the mine workings underneath property footprints. Meant we had to go and sort of shutter and barrier off the treatment areas so that we only filled the mine underneath the property, because obviously they didn't want to pay for anything else. So the rest of the mine is still open. Top right, that's a big infilling plant. That some of the bigger jobs we do, that will output 230 cubic metres an hour of grout, and you can pump PFA grout a long way. That injection point into a big limestone mine working is probably about 2 kilometres from the mixing plant. So, a number of challenges, I think, of industry academia connections in terms of our sort of business. I mean, we are able to, as a company, we're able to provide work experience opportunities, and we do regularly. And obviously we're able to work with Birmingham this year on a student group for project experience. I think we had seven students who came in and worked on a project with us. They were, I think, third year students. And we can offer work placement opportunities, and I think 2 of the students that came in we have taken on this year to give them work experience opportunities for summer vacation. So the group project work, basically we gave them a project that we'd already carried out, so we knew we knew all the information, we had all the documentation, we knew what had been done to complete the project, so we were able to give them a set of information to go away with, having introduced them to mine workings treatment and explained it in sort of detail, and given them the various documentation for them to read that are the sort of template specifications, that sort of thing, and allowed them to go and complete their own designs based on that information, and come back to us and say, well, this is what I think. Is that the reality? Is that what's real? What have you sort of done? So we're able to help them out with questions, but to a certain extent, once we'd introduced it, leave them to it to come up with their own solutions, and then sort of peer review them at the end to make sure they've got an understanding of what they've done right, perhaps what they've done wrong, etc. And that's something we're quite happy to host again. We were pleasantly surprised, shall we say, at how interested the students who came in were. Some of them were more interested than others, but it was a very useful opportunity for us, and it certainly exposes some of the students from this department to the type of work we do, and obviously other similar organisations who are more in the contracting fraternity rather than consulting or designers, what we get up to. Now I think it's one of the things about the construction industry generally, it tends not to publicise itself very well. Most sites are hidden behind fences, and you can't often see what's going on. So we were able to take the group of students out to site and show them a working site. Drilling and grouting is not, it's not a particularly clean operation. Drilling in generally can be quite dirty, and sites can get quite mucky. So it really is for those students who are really interested in a career outside. But I mean, it is outside. It's in the open air. Lots of good contracts, lots of big contract values, and some sites, as I say, with some big management teams on. So you get a lot of good experience. We as a business, I mean, we do take on vacation students, work experience or placement students. And from a sort of permanent staff point of view, we probably take on a graduate every 2 years. That can either be a civils graduate or a ground engineering graduate. I think some other challenges, I think universities' knowledge of work experience opportunities is presumably hard to get, because we probably don't advertise ourselves like a lot of other businesses saying we've got these opportunities available. And on a lot of occasions, work experience opportunities tend to come through word of mouth. A friend will ring you up and say, "Oh, my son's doing civil engineering, can he come and do a year's work experience, or a summer's work experience?" So I think it's very useful for to expand the contacts between university departments, particularly earth sciences, and those businesses who are working in that field. So having done it this year, we're very happy to continue doing it in future years. And it's also encouraging businesses to make the time to host work experience, because a lot of businesses think, "Oh, we're too busy, you can't afford to allocate staff." And, it doesn't actually take up much time. Once you've introduced a subject to a group of students, particularly if it's a project, allow them to go away, do the research, make their sort of initial stab at solutions and that sort of thing. You perhaps might only have to host one meeting or one question session. And then similarly, if you're doing summer work experience, once you've done your initial induction and you've placed a student with a site team, as long as they're interested, then they'll learn a lot during that summer period. One of the things I would say is with the project work, I think we found that we probably needed more time up front to sort of prepare the project, and I think the students could probably have done with more time, because I think they ended up with a month to do the project, which, as well as all the other work they're doing in the final year, is probably not enough. So certainly if we're doing it next year, we'd get involved earlier to make sure that could be accommodated. And I think that's particularly the case when perhaps they're introduced to a new area of ground engineering or geotechnics. It's something perhaps they haven't done very much of during the university course. Inevitably, some of the group is more interested than others, but we were really pleased to see how interested they were in this particular field. Just a couple of things from a contractor's point of view, and this is not just in ground engineering. This is in university courses per se, and it was the same when I was at university. We often find university courses are very much academic related or consultant based, if that's the right way of putting it. So students don't arrive with us, I might call it oven ready, or with skills to immediately sort of go to work in the contractor environment, which obviously is the site-based environment. And it's things like health and safety training. We can't send anybody on site these days without people having a health and safety qualification. We have to register people with the CSCS, the Construction Skills Certification Scheme. And it would be useful if students had done some surveying, perhaps GPS surveying, and understood a bit maybe about programming and contracts, the forms of contract, that sort of thing, to make them a bit more useful, if you like, when they arrive on site. Otherwise, we end up having to do quite a bit of sort of induction and preparation training before they start being useful. Now, I don't know whether that's something that there is time to introduce into curriculums, but it would help from the contractor's point of view, maybe not the consultant's point of view, if they could be a bit more, shall we say, oven ready. And I'm not sure whether there's the opportunity to have discussions with organisations like CSCS to see whether there's an opportunity to develop a student card, which would have involved some health and safety training. I mean, the health and safety training is just a day. It's a day's course and it's a touchscreen test, but they've done it. And I think that's probably one of the things that perhaps puts some employers off taking people on work experience, is you have to put them through this sort of introductory training before you can allow them onto site. And of course, CSCS, if you don't know it, is an NVQ-based system, so you spend 3 or 4 years doing your degree, and then you start on site, and then you've got to go and do a different sort of training with the NVQ, which is all it's all experience-based training. But I'm sure there should be a link between the two, so we're not starting again with a different form of training. So that was me, actually. So thank you. Do you want to can I take that out, or do you want to leave it?
Yeah, some really interesting points there, which I know we've discussed recently as well, particularly regarding the health and safety qualification. Something we're seriously thinking about implementing. So we'll discuss that.
Okay. Thank you.
So finally, we have